What if I told you the Big Bang never happened? Not because some religious zealot wants it that way, but because the very question, what happened before, is like asking what's north of the North Pole. You see, we've been trained to think time is this river flowing one direction, past, present, future. But what if time itself is the illusion? What if the universe didn't start at all, but we just can't think outside the box our brains built for us? Stick with me, because once you see what I'm about to show you, you'll never look at a clock, a birthday, or even your own mortality the same way again. Now I know what you're thinking. You're thinking, Feynman, you've lost it. I've seen the documentaries. I've read the articles. The Big Bang is settled science. We know the universe is 13.8 billion years old. We have the measurements. We have the cosmic microwave background. We have Edwin Hubble's observations. This is done. This is proven. And you know what? You're both right and catastrophically wrong at the same time. And that's exactly where this gets interesting. Here's what this video is going to do for you that no one else is willing to say out loud. It's going to give you permission to stop pretending you understand something you don't. And more importantly, it's going to show you why not understanding is actually the more intellectually honest position, and ultimately the more liberating one. You've been lied to. Not maliciously, but culturally. You've been told that science has proven the universe began 13.8 billion years ago in a cosmic explosion. You've seen the graphs, the cosmic microwave background radiation maps, the confident pronouncements from scientists in lab coats standing in front of blackboards covered with equations, and somewhere deep inside, you nodded along while a quiet voice whispered, "But what was before that?" And when you asked, maybe to a teacher, maybe to a professor, maybe just to yourself late at night, you got hand-waved away with, "Time didn't exist yet," or, "That question is meaningless." And it felt like a cop-out, didn't it? Because it is a cop-out. Here's the reframe I want you to hold on to. The Big Bang is not a creation event. It's a description of what happens when we run our best equations backward until they break. It's the horizon of our current understanding, not the edge of reality. Confusing the two is like ancient sailors thinking the ocean ended where their maps did. They'd draw their beautiful charts, accurate and detailed for the waters they'd sailed, and then at the edge they'd write, "Here be dragons." Not because there were actually dragons out there, but because that's where their knowledge stopped. That's where the map ended. We've done the exact same thing with the Big Bang. We've found the edge of our map and declared it the edge of the world. What you're going to get from this video is clarity about what we actually know versus what we've mythologized. You'll learn to think like a physicist, to hold uncertainty without collapsing into either dogma or nihilism, and you'll walk away with a completely different relationship to existence itself. Not as a thing that started, but as a thing that simply is, in ways our monkey brains are only beginning to glimpse. This isn't about answers, it's about upgrading your questions, it's about learning to be comfortable in the vast, beautiful, terrifying space of not knowing. So let me take you on a journey, not through space or time, but through the architecture of how we think about space and time. Because that's where the real revolution happens. Not in the data, not in the telescopes, but in the way we frame the questions we're asking. Imagine you're an ant. I want you to really picture this. You're an ant, and you live your entire life on the surface of a balloon that's being inflated. You don't know it's a balloon, of course. To you, this surface is the entire universe. It's all that exists. You can walk north, south, east, west across this surface, and it seems infinite to your tiny ant perspective. But here's the thing that's happening without your knowledge. The balloon is being slowly, steadily inflated. And as it inflates, you notice something absolutely remarkable. You notice that all the other ants, every single one, is moving away from you. No matter which direction you look, everyone's receding. The ants to your north are getting farther away. The ants to your south are getting farther away. Every ant, in every direction, moving away from you at the center. Now, you're a smart ant, a physicist ant. You went to Ant University, you studied ant mathematics, and you're good at this. So you start thinking. You think, if everyone's moving away from me and I run this process backward in time, that means we all used to be closer together. In fact, if I extrapolate backward far enough, there must have been a moment when we were all touching. There must have been a beginning, a moment zero, when all the ants were in the same spot. So you start calculating. You measure the speeds at which the other ants are receding. You work backward. And you find it. You calculate that 13.8 billion ant seconds ago, you were all at a single point. The great squish, the primordial touching of all ants. You announce your discovery, you publish papers, you give lectures, you win the Ant Nobel Prize, you're famous, you're celebrated, you've discovered the origin of the universe. But here's what you missed, and this is crucial. You live on a surface. The balloon has no center on the surface itself. If you're an ant confined to the two-dimensional surface of the balloon, there's no special point that's the center from your perspective. Every ant can legitimately claim to be at the center because everyone else is moving away from them equally. The expansion is happening everywhere at once. The beginning, you calculated, that primordial point where all ants were touching. It isn't a place on the balloon. It's when the balloon was deflated down to nothing. But here's the question that should haunt you. Does that mean the balloon itself didn't exist? Or does it just mean the balloon was in a different state? Maybe the balloon was always there, just scrunched up, compressed, waiting to be inflated. Maybe the balloon goes through cycles, inflating, deflating, inflating again, like a cosmic lung breathing in and out. Maybe there are infinite other balloons you can't see, can't detect, because you're trapped on the surface of your own. The point is this, and I need you to really hear this. Your equations describe the surface's expansion perfectly, beautifully, with stunning accuracy. But they can't tell you what the balloon is made of. They can't tell you whether it had a creator who tied it off and started blowing. They can't tell you what's outside the balloon in the larger room. You've described motion brilliantly, but you've mistaken that description for ultimate truth. You've confused the map for the territory. That's us. We're ants on a surface. We're trapped in our 3 spatial dimensions plus time, extrapolating backward to a singularity and calling it the beginning. We're calling it the Big Bang and declaring the case closed. But we might just be at the limit of what our dimensional perspective can see. We might be looking at the edge of our map and mistaking it for the edge of reality. And you know what's beautiful about this? It means the mystery is deeper than we thought. It means reality is more interesting, more strange, more provocative than everything started 13.8 billion years ago and will end in heat death. That story is too small, too tidy, too convenient for creatures who desperately want beginnings and endings because that's how we understand our own lives. But wait, if the Big Bang isn't the beginning, then what is it? What are we even talking about when we say Big Bang? Hold that question. Let me show you something even stranger first. Let me tell you about a student I once had. I had this student, brilliant kid, genuinely one of the sharpest minds I'd encountered in decades of teaching. Sharp like a knife. Sharp like broken glass. The kind of smart that sometimes cuts yourself on. He came to my office one afternoon, and I could see he was absolutely tortured. Hadn't slept. Had that wild look in his eyes that you get when you've been thinking about something so hard that you've forgotten to eat, forgotten to blink, forgotten that other people exist. I knew that look. I'd worn it myself many times. He sat down and he said, "Professor Feynman, I've been thinking about time, specifically about how time could begin, and I'm stuck. I'm completely stuck, and it's driving me insane." I leaned back in my chair and said, "Okay, tell me about it." And he starts talking, fast, like if he slows down he'll lose the thread. He says, if time started at the Big Bang, what does start even mean? To start implies a before state and an after state. Something wasn't happening, and then it was happening. But if there's no time before the Big Bang, the word start becomes meaningless. We're using language that requires time to describe the origin of time. We're trapped in circular logic. It's like trying to use a ruler to measure the first inch of the ruler itself. I looked at him for a long moment, and I said, "You're absolutely right. You've discovered something that most physicists spend their whole careers very carefully avoiding thinking about too hard." He looked relieved for about half a second, and then the relief turned to terror. "So, what do we do? If the language doesn't work, if the concepts don't work, what do we do?" And I told him something I want you to hear too. I said, "We get comfortable with paradox. We accept that our language, the words we use, the grammar we think in, evolved to describe medium-sized objects moving at medium speeds through medium amounts of time, rocks and trees and people and horses. That's what our brains are built for. That's what language is optimized for. When we try to apply that language to the origin of the universe, to the nature of time itself, it breaks. Not because we're stupid, not because we're doing it wrong, but because we're asking our tools to do something they weren't built for. It's like trying to use a ruler to measure justice or a thermometer to measure love. The tool isn't broken. The tool is just the wrong tool for the job." The student sat there quietly, processing. Then he asked the question I'd been waiting for. He said, "But doesn't that mean we can't really know? Doesn't that mean this whole enterprise is kind of futile?" And I said, "Exactly. We can describe, we can measure, we can predict with astonishing accuracy. But knowing in the deep, ultimate, capital K knowing sense, that might not be available to creatures with our cognitive architecture. We might be like dogs trying to understand calculus. Not because dogs are dumb, dogs are great, but because their brains aren't wired for abstract mathematical reasoning. Similarly, our brains might not be wired to comprehend the true nature of time and existence." I leaned forward and I said, "And you know what? I find that deeply comforting. I find it beautiful, because it means the universe is more interesting than our brains. It means reality is under no obligation to make sense to us. It means there's genuine mystery baked into the structure of things, and no amount of clever equation writing will dissolve it completely. That doesn't make science useless. It makes science humble. It makes science honest." He left my office still troubled, but differently troubled. Before, he was troubled by the paradox itself. Now he was troubled by the infinity of what might lie beyond the paradox. That's progress. That's the beginning of real thinking. That's the moment when you stop being a student reciting answers and become a scientist grappling with reality. So if our language breaks down, if our concepts fail us, how do we think about this? What tools do we actually have? Let me show you what the math says, and more importantly, what it doesn't say. All right, story time is over. Let's get into the deep water. I'm going to give you 3 core truths that will completely reframe how you think about existence, time, and what we call the beginning. These aren't easy truths. These aren't comfortable truths, but they're honest truths. And I think you'd rather be uncomfortable and honest than comfortable and deluded. First truth: the Big Bang Theory doesn't explain where the universe came from. It describes what happened after a certain point. This distinction is absolutely crucial, and it's where most people get confused. So let me walk you through this carefully. When Edwin Hubble looked through his telescope in the 1920s, he noticed something shocking. He was measuring the light from distant galaxies, and he noticed that the light was shifted toward the red end of the spectrum. Now, this is important because of something called the Doppler effect. You know how an ambulance siren sounds higher pitched when it's coming towards you and lower pitched when it's moving away? That's the Doppler effect. Waves get compressed when the source moves toward you and stretched when it moves away. Same thing happens with light. Light from objects moving toward us shifts blue. Light from objects moving away shifts red. Every galaxy Hubble looked at, every single one, was redshifted. They were all moving away from us. All of them, in every direction. And here's the kicker. The farther away they were, the faster they were receding. This was observational gold. This was the kind of data that makes physicists wake up in the middle of the night, excited. It meant the universe was expanding. Not that things were flying apart from some central explosion point, but that space itself was stretching, carrying galaxies along with it like raisins in rising bread dough. Now, if things are getting farther apart right now, run the film backward and they must have been closer together in the past. Simple logic. Undeniable logic. Run it back far enough and you get to a state of incredible density and temperature. Everything squished together, compressed, unimaginably hot. This is what we call the Big Bang state. We calculate that about 13.8 billion years ago, everything we can observe in the entire universe was compressed into an unimaginably small, hot, dense point. Smaller than an atom. Maybe infinitely small. The math suggests a singularity, a point of infinite density. Now notice what I didn't say. Notice very carefully what I didn't say. I didn't say, the universe was created 13.8 billion years ago. I said, the observable universe was compressed into a hot, dense state. Big difference, enormous difference, universe-sized difference. The Big Bang theory describes cosmic expansion. It makes very specific, testable predictions. It says, if this is true, the universe should be cooling down as it expands, just like air cools when you let it out of a compressed tank. Check, it's cooling. The theory says there should be background radiation left over from the early hot state, a kind of afterglow from when the universe was so hot that atoms couldn't even form. Check, we found it in 1965. The cosmic microwave background radiation. It's everywhere. It's perfect. It's exactly what the theory predicted. The theory says the proportions of hydrogen and helium in the universe should match certain very specific calculations based on conditions in the early universe. Check. They match to absurd precision. Every prediction checks out. Every test passes. The theory is spectacularly, breathtakingly successful. It's one of the great triumphs of human reasoning. I'm not here to tear it down. I'm here to clarify what it actually says versus what people think it says. Here's where people get confused, where the slippage happens. Successful description doesn't equal ultimate explanation. The theory tells us the universe was in a hot, dense state and expanded. Full stop. That's what it tells us. It doesn't tell us why it was in that state. It doesn't tell us what before means, or if before is even a coherent concept. It doesn't tell us whether time itself had a beginning, or whether time is something more fundamental. It doesn't tell us whether our universe is all that exists, or whether it's one bubble in an infinite foam of other universes. We've done something psychologically slippery, something very human and very understandable, but ultimately misleading. We've taken a scientific model with precise, limited claims, and we've inflated it into a creation myth. We've turned the universe expanded from a hot, dense state into the universe exploded into existence from nothing. That second version? That's not science. That's storytelling. That's us satisfying our deep psychological need for beginnings and endings, for stories with a chapter 1. Science is humbler than that. Real science says, here's what we can measure. Here's what the math predicts. Here's the boundary where our equations break down, and we honestly don't know what's happening anymore. That last part, the breaking point, that's where the Big Bang actually sits. It's not the beginning of everything. It's the beginning of what we can currently describe with our current tools. Think of it like this. Imagine you're watching a movie and you walk into the theater late. The movie is already playing. You see characters in the middle of an argument. You can describe what you're seeing. You can say, the man is angry, the woman is crying, they're in a kitchen. All true, all accurate, but you don't know why they're arguing. You don't know what happened before you walked in. You don't know if this is the first time they've fought or the 100th. You're describing the middle of a story and calling it the beginning because it's where your observation began. That's us with the Big Bang. We're watching the universe expand, and we're running the footage backward until the film gets too damaged to read. And we're calling that first unreadable frame the beginning, because it's where our ability to see clearly stops. But the movie might have been playing long before we walked in. So if the Big Bang is just where our math breaks, what happens when we try to push past it? What's on the other side of that wall? And that brings me to the second truth, the one that really scrambles people's brains. Second truth. Time is not a river flowing from past to future. It's more like a dimension, similar to space. And once you really understand this, everything changes. Everything. In our everyday experience, time feels absolute. It flows. It marches forward relentlessly. You're born, you age, you die. Eggs break, but don't unbreak. Milk spills, but doesn't unspill. The arrow of time seems undeniable, carved into the bedrock of reality. This is how we experience the world. This is how we think. But Einstein showed us something radically different. He showed us that time is relative. It bends, it stretches, it slows down near massive objects, or when you're moving at high speeds. There's no universal now that everyone agrees on. An event that's in your past might be in someone else's future, depending on your relative motion. If you're standing still and I'm flying by you in a spaceship at near the speed of light, we will literally disagree about what's happening right now on a distant star. Not because one of us is wrong, but because simultaneity itself is relative. Now is not an absolute concept. It's observer-dependent. This is weird. This is deeply, fundamentally weird. But it's not speculation. It's measured. It's tested. We have atomic clocks on airplanes and satellites that run at different speeds than clocks on the ground, exactly as Einstein predicted. Time is not the rigid framework we thought it was. It's flexible. It's part of the fabric of space-time, woven together with the 3 dimensions of space into a 4-dimensional whole. Now, when we combine this with quantum mechanics, things get truly bizarre. At the quantum level, particles don't have definite pasts until we measure them. There's this famous experiment, Wheeler's delayed choice experiment, that suggests the past can be influenced by measurements we make in the present. You can set up a situation where you decide how to measure a photon after it's already passed through a certain point, and your choice affects what the photon did back then. It's as if the past isn't fixed until you look at it. Causality itself becomes fuzzy, uncertain, negotiable. I know this sounds like science fiction. I know it sounds like I'm making this up. But this is the world quantum mechanics reveals to us. This is what the experiments actually show, again and again and again. Now apply this understanding to the Big Bang question. We ask, what happened before the Big Bang? But that question assumes something very specific about the nature of time. It assumes time is a container that existed independently, sitting there empty, waiting to be filled with events. It assumes time is the stage, and the universe is the play happening on that stage. But what if that's wrong? What if time itself is a property of the universe, not something the universe exists inside of? What if time is as much a part of the physical system as matter and energy? If time is a dimension woven into space-time, and space-time itself emerged from or expanded from the Big Bang state, then asking what came before is like asking, what's north of the North Pole? Think about that for a second. What's north of the North Pole? The question sounds reasonable. It has grammatical structure. It uses familiar words, but it contains a category error. Once you're at the North Pole, the concept of north loses meaning. Every direction is south. There is no more north to go. The question dissolves when you understand the geometry of the Earth properly. Similarly, if time is a feature of the universe that emerged with or from the Big Bang, there might be no before. Not because something prevented events from happening before, but because before requires time, and time might not exist independently of the physical universe. The question might contain a category error. It might be asking for something that's incoherent once you understand the actual structure of reality. But, and this is crucial, we don't know that time began. We don't know that for certain. We just know our current equations stop working at a certain point. They give us infinities. They give us nonsense. They break down. Maybe time really did begin with the Big Bang. Maybe it didn't. Maybe time is cyclical, looping back on itself. Maybe time is an emergent property of something deeper, some more fundamental substrate we haven't discovered yet. Maybe there are regions of a larger reality where time flows differently or doesn't exist at all. The honest answer, the only honest answer, is we don't know. But here's what's beautiful about this. Recognizing the limits of our concepts, recognizing that time might be a provincial, local phenomenon specific to our patch of reality, opens the door to possibilities way weirder and more wonderful than the universe started 13.8 billion years ago, and that's that. It means the mystery is deeper than we thought. It means we're still at the beginning of understanding, not the end. And that's exciting. That's the opposite of disappointing. That means there's still work to do, still questions to ask, still reality to grapple with. And if time itself is negotiable, if our basic framework is potentially flawed, what does that mean for the idea of a beginning at all? What does creation even mean if time doesn't flow the way we think it does? Let me show you where modern physics is actually heading with this. Let me show you the cutting edge, third truth. And this is the one that breaks people's brains. This is the one that makes people angry, uncomfortable, disoriented. Maybe there was no beginning. Maybe infinity is not a bug in our thinking. Maybe it's a feature of reality. Humans hate infinity. We are deeply, viscerally uncomfortable with it. It makes us want to run away. We want edges. We want boundaries. We want starts and stops. We want to point to a moment and say, there, that's when it began. It gives us psychological closure. It lets us sleep at night. Even physicists, people who should know better, people who work with infinity in their equations every single day, rush to insert a creation event into cosmology, because the alternative is too vertiginous, too dizzying, too much. But look at what modern physics is actually telling us when we're brave enough to listen. Look at where the math is pointing. Some versions of quantum cosmology suggest the universe could be in an eternal quantum state with no definite beginning. In these models, what we call the Big Bang is just one fluctuation, one particular expression in an infinite field of quantum possibilities. The universe doesn't start. It's always in a superposition of states, and the Big Bang is the crystallization of one particular outcome. But the underlying quantum field? That might be eternal. No beginning, no end, just an infinite space of possibilities, constantly collapsing and recollapsing into concrete realities. Then there are the cyclic models. These propose the universe goes through infinite cycles of expansion and contraction. Big Bang, expansion. The expansion slows, reverses, everything collapses back into a big crunch, which then triggers another Big Bang. Over and over, infinite cycles, no beginning to the chain, no end. Just eternal breathing in and out, expansion and contraction, like a cosmic lung that's been breathing forever and will breathe forever. There's eternal inflation theory. This suggests our Big Bang was just one bubble in an eternally inflating multiverse. Picture a pot of boiling water. Bubbles form, expand, pop. New bubbles form. The process never stops. Each bubble is a universe with its own Big Bang, its own laws of physics potentially, its own timeline. And the underlying field that's producing these bubbles? That's eternal. It's always been inflating, always will be inflating. Universes are being born constantly. The process never started and never ends. Our Big Bang was just one bubble forming in an infinite sea of bubble universes. And then, even stranger, Some interpretations of quantum mechanics suggest removing time altogether from the fundamental equations. In these frameworks, time is an illusion, an emergent property of our macroscopic experience. At the deepest level of reality, everything just is. Timelessly, eternally existing. The whole history of the universe, past, present, and future, exists all at once in a timeless quantum state. Time is something that emerges when you look at the system from the inside, from the perspective of a conscious observer embedded in the system. But fundamentally, no time, no sequence, no before or after, just existence. Now, none of these are proven. I want to be crystal clear about that. These are speculative. These are hypothetical. These are physicists taking the math seriously and asking, what if we follow these equations all the way? What do they imply? They're not fringe nonsense. These are serious proposals published in serious journals by serious physicists. But they're not settled. We don't know which, if any, is correct. But here's the pattern I want you to notice. Here's what's happened again and again throughout the history of science. Every time we think we've found a boundary, a limit, an edge to reality, we later discover it was just a limit of our perspective. The Earth feels flat when you're standing on it, but it's not flat. It's round. The horizon isn't the edge of the world. It's just the edge of what you can see from where you're standing. The solar system isn't the universe. It's one solar system among billions in our galaxy. The Milky Way isn't the only galaxy. It's one galaxy among hundreds of billions in the observable universe. The universe isn't static. It's expanding, dynamic, evolving. Every time. Every single time. We thought we had it figured out, and reality was bigger, stranger, more extravagant than we imagined. So why would the beginning be any different? Why would this be the one time where we actually found the real edge, the real limit? Isn't it more likely that the Big Bang is another horizon, not an edge? Another limit of our current perspective, not the boundary of reality itself? Maybe the universe doesn't owe us an origin story. Maybe existence is more fundamental than causation. Maybe the question, why is there something rather than nothing, is as confused as asking, why is there up rather than down? That second question presumes a symmetry that doesn't exist. Up and down aren't opposites in some cosmic scale. They're directions relative to a gravitational field. Without gravity, without mass, the concepts lose meaning. Similarly, maybe something versus nothing is a false dichotomy. Maybe nothing isn't even a coherent concept. Maybe existence is the ground state. Maybe the default. Maybe asking why there's something rather than nothing is like asking why there's existence rather than non-existence, when non-existence might not even be a possible state of affairs. This isn't defeat. This isn't me throwing up my hands and saying we can never know anything. This is liberation. This is permission to stop torturing yourself trying to imagine what nothingness looks like. Permission to stop trying to conceive of before time. You can accept that some questions might dissolve when we understand them more deeply, that some questions reveal themselves to be based on flawed premises. The terror of infinity becomes the wonder of infinity. The discomfort of not knowing becomes the excitement of genuine mystery. You don't have to have it all figured out. You don't have to pretend certainty. You can sit in the uncertainty and find it beautiful. Okay, I've just thrown a lot at you. Metaphors and paradoxes and speculative physics and ants on balloons and movies and North Poles. Your brain is probably doing somersaults right now. You might feel a little dizzy, a little unmoored. That's normal. That's good, actually. That means you're actually thinking about this, not just passively absorbing it. So let me bring this down to earth. Let me give you 3 practices, 3 ways to actually use this understanding in your life, in your thinking right now. Because philosophy that doesn't change how you live isn't philosophy. It's just word games. First practice, and this is the hardest one for most people. Start noticing when you're pretending to understand something you don't. and practice saying out loud, "I don't know," and that's okay. This sounds simple, it sounds trivial, but it's radical. It's revolutionary. We live in a culture that rewards certainty, confidence, having answers, being decisive. Saying "I don't know" feels like failure, feels like you're not smart enough, like you haven't done your homework, like you're falling behind all the people who seem to have it figured out. But here's the secret, and I've known this for 70 years of doing physics. The smartest people I've ever known, the real geniuses, the ones who actually moved the field forward, are comfortable with uncertainty. They can hold a question without collapsing into a premature answer. They can say, "This is fascinating, and I don't understand it yet, and I'm going to keep thinking about it." They don't need the psychological comfort of a tidy answer. They're comfortable in the mess. The people who pretend to know everything, they're either lying or deluded, and usually both. The universe is too big, too strange, too complex for any human brain to fully comprehend. Anyone who tells you they have it all figured out is selling you something. So try this. Try it this week. When someone asks you a big question about God, about meaning, about consciousness, about what happens after death, about how the universe started, instead of reaching for a comfortable cliché or a half-believed answer you picked up somewhere, try saying, "I don't know. I've thought about it, and I genuinely don't know. Isn't that interesting?" Watch what happens. Some people will be uncomfortable. They'll push back. They'll say, "But you must have some theory." They need you to play along with the game of certainty. That's fine. Let them be uncomfortable. But other people, the interesting ones, will lean in. They'll say, "Me neither." And suddenly you're having a real conversation instead of a tennis match of certainties. You're actually exploring together instead of defending positions. Not knowing isn't ignorance. Not knowing is the starting point of wisdom. It's the doorway to actual learning. As long as you think you already know, you can't learn anything new. Your cup is full. But empty your cup, admit you don't know, and suddenly there's room for reality to surprise you. Second practice. When you hear a scientific claim, any scientific claim, ask yourself, is this describing what happens or explaining why it happens? This distinction is everything. This is the difference between science and scientism, between understanding and ideology. The Big Bang Theory describes cosmic expansion. It doesn't explain why expansion occurred in the first place. Evolution describes how species change over time through mutation and selection. It doesn't explain why life exists at all or why the universe is capable of producing self-replicating systems. Quantum mechanics describes the behavior of particles with extraordinary precision. It doesn't explain why reality is quantum, why the universe operates according to these particular rules rather than some other rules. This distinction matters enormously. Most arguments between science and religion, between materialism and spirituality, between different worldviews happen because people confuse these levels. Someone says, "Science has shown that the universe began with the Big Bang." But what they mean is, science has described a pattern of cosmic expansion. The listener hears, "Science has explained the ultimate origin of everything, and there's no room for anything else." And then the fight starts. But the fight is based on a confusion. Practice catching this in real time. Listen to a documentary about cosmology. Read an article about neuroscience and consciousness. Notice when "we have observed X" slides imperceptibly into "therefore Y is the ultimate truth about reality." Notice when a map is being sold as the territory. Notice when description is being inflated into metaphysics. This doesn't make science less valuable. It makes it more valuable. Science is astonishingly good at description and prediction. That's its superpower. That's what it's optimized for. We can describe how stars form, how light bends around massive objects, how chemicals react, how genes are expressed. We can predict eclipses centuries in advance, land robots on Mars, cure diseases, build computers. This is extraordinary. This is humanity at its best, but demanding that science also provide ultimate meaning, ultimate purpose, the answer to why is there something rather than nothing, is like demanding your thermometer tell you who to marry. It's the wrong tool for the job. The thermometer is great at measuring temperature. Don't get mad at it for not solving your relationship problems. When you can distinguish these levels clearly, you stop expecting physics to answer philosophical questions, and you stop dismissing philosophy as just speculation that's inferior to science. You can hold both. You can be rigorously scientific about what science can address, and rigorously philosophical about what it can't. You can be scientific and humble about the limits of science at the same time. Third practice, and this one might sound weird, but trust me on this. Spend 5 minutes this week sitting with the feeling of infinity. Just the raw feeling. Not thinking about it. Not analyzing it. Just feeling it. Here's how you do it. Find a quiet place. Close your eyes. Take a few breaths. Now imagine space extending outward from where you're sitting. Outward past the walls of your room. Past your house. Past your city. Keep going. Past the Earth. Past the solar system. Past the galaxy. Past the cluster of galaxies. Farther, farther. Imagine it never stopping, never ending. No wall, no edge, just more space. Forever. Notice what happens in your body when you do this. Does your stomach drop a little? Does your breath catch? Do you feel a little dizzy, a little vertiginous, maybe a little awe, maybe a little terror, maybe both at the same time? Good. That's the feeling I want you to notice. Sit with it. Don't try to resolve it. Don't reach for a comforting thought like, but God contains it all, or, but it probably does end somewhere we just can't see. Just sit with the raw experience of endlessness. Let yourself feel small. Let yourself feel the scale. Then do the same thing with time. Imagine the past extending backward. Before you were born. Before your parents were born. Before humanity existed. Before the Earth formed. Before the solar system. Before the galaxy. Keep going backward. Before the Big Bang. Keep going. Imagine it never starting. No first moment. Just infinite past extending backward forever. Notice the discomfort. The way your mind wants to flinch away. Stay with it. Breathe. Feel it. This isn't about reaching a conclusion. This isn't an intellectual exercise. It's about training your nervous system to tolerate uncertainty and vastness without shutting down. Most of us never do this. We think about infinity for 3 seconds, feel uncomfortable, and immediately grab our phone to distract ourselves with something manageable, something finite, something we can control. But if you can sit with it, if you can really sit with the feeling of infinity for even just 5 minutes, something shifts. The terror becomes curiosity. The vertigo becomes awe. You start to understand viscerally, not just intellectually, that the universe is under no obligation to make sense to you. That reality is bigger than your ability to conceptualize it. And paradoxically, instead of making you feel disconnected or small in a bad way, it makes you feel more connected, more part of it, because you're not fighting it anymore. You're not demanding it fit into your categories. You're letting it be what it is. 5 minutes. This week. Try it. See what happens. I think you'll be surprised. All right, let's bring this home. Let's land this plane. We started with a question that's been haunting humanity since we first looked up at the stars and wondered, where did all this come from? How did it begin? Why is there something rather than nothing? These are the deepest questions we can ask, the most profound, the most important. And I told you something uncomfortable. I told you we don't know. The Big Bang isn't the answer you thought it was. It's not a creation event where the universe exploded into existence from nothing. It's a description of cosmic expansion. It's the horizon of our current understanding, not the edge of reality itself. It's where our equations break down, and we have to be honest and say, beyond this point, we're guessing. But here's what you've gained. Here's what's different now from when we started. You've learned to think like a physicist. Not like a physicist in the sense of memorizing equations. Anybody can memorize equations. But thinking like a physicist in the deeper sense. You've learned to distinguish what we know from what we've mythologized, to separate description from explanation, to get comfortable with uncertainty without collapsing into either dogmatic certainty on one side or nihilistic despair on the other. You've seen that time might not be what you think it is, that it's not this rigid container everything happens inside of, but a flexible dimension woven into the fabric of space-time itself. And if time itself is negotiable, if time might be emergent or cyclical or even illusory at the deepest level, then the whole question of the beginning transforms. It might not even be the right question to ask. You've seen that infinity might be more real than beginnings, that the universe might be eternal in ways we're only starting to glimpse, that what we call the Big Bang might just be one event in an infinite process, one bubble in an eternal foam, one cycle in an infinite series of expansions and contractions. And most importantly, you've learned that the smartest thing you can do is admit when you don't know. That intellectual humility isn't weakness, it's strength, it's honesty. It's the only rational response to a universe this vast, this strange, this beautiful. This isn't just about cosmology. This is about how you hold reality. Do you need tidy answers to sleep at night? Or can you dance with mystery? Can you be intellectually honest and emotionally okay at the same time? Can you sit with the big questions without immediately reaching for comfortable lies? Here's what I want you to remember. Here's what I want you to come back to when the vertigo hits, when the uncertainty feels overwhelming, when you're lying awake at 3 in the morning trying to imagine what before time could possibly mean. Here's your mantra. You are not broken for not understanding infinity. You're human, and your confusion is not a flaw. It's not a sign that you're not smart enough or haven't thought hard enough. It's your brain brushing up against something bigger than itself. That's not failure. That's contact with the real. That's your mind touching the edge of what minds can do. And that's beautiful. That's precious. That's the most honest thing you can experience. The universe didn't start with the Big Bang. Or maybe it did. Or maybe the question itself is confused. We don't know. But your willingness to think clearly, to be honest about what we know and what we don't, to hold uncertainty with grace, that can start right now. That's available to you immediately. You don't need a PhD in physics. You don't need to understand the equations. You just need to be willing to say, I don't know, and I'm okay with that. If this resonated with you, if you felt something shift even a little, if some knot of confusion loosened just slightly, do me a favor, hit the like button. Not for the algorithm, though that helps too, but because it tells me I'm not alone in thinking we need more honest conversations about what we don't know. It tells me there are other people out there who are tired of fake certainty and hungry for real thinking. Drop a comment and tell me, what's the question you're most comfortable not having an answer to? What's the mystery you've made peace with? I read every single comment, and I learn from you. Some of the best insights I've had have come from conversations in the comments. You're not just an audience, you're part of this exploration. And if you want more of this, more thinking that doesn't insult your intelligence or pretend certainty where there isn't any, subscribe. Stick around. Let's keep asking the hard questions together. Let's keep pushing against the boundaries of what we can know. Let's keep finding the beauty in not knowing. Because the universe didn't start with the Big Bang. The universe is weirder, more mysterious, more wonderful than that. And the adventure of trying to understand it, of bumping up against the limits of what human minds can comprehend, that's what makes life worth living. Thanks for watching. Now go sit with infinity. Let it wash over you. Feel how small you are and how connected you are at the same time. I'll be here when you get back.
What if the Big Bang wasn't a beginning at all, but more like a middle?
Not the first page of the universe's story, but maybe page 10,000 of an infinitely longer book you were never shown. Here's what bothers me. We named it a bang, which already tells you everything about how humans think. We needed a sound, a starting gun, a moment to point at and say, there. That's where it started. But the universe didn't ask for our comfort. It didn't arrange itself around our need for a clean origin story. So what if, just what if, asking what came before the Big Bang isn't a stupid question? What if it's the only question that matters? I want to stay with that for a moment before we go anywhere else. Because I know what happens when most people ask that question in a classroom, or at a dinner table, or in a comment section somewhere. Someone with a confident voice, a teacher, a documentary narrator, a very smart friend. They smile that particular smile, the patient smile. And they say, well, the question doesn't really make sense. Time itself began at the Big Bang. There is no before. Asking what came before the Big Bang is like asking what's north of the North Pole. And you nod. Because that's a beautiful answer. It's elegant, it has a certain finality to it. And you walk away feeling like you just learned something profound. But somewhere in the back of your mind, and I mean the very back, the part you don't usually let talk at dinner, something keeps pulling at you. Like a loose thread. Like a door that looks flush with the wall but has a draft coming through it. You felt the draft, didn't you? That's why you're here. That draft is real. And today, we're going to walk through that door together. I have spent my entire career being suspicious of clean answers. Not because I enjoy being difficult, though, if I'm honest, there's some of that, but because in my experience, the cleaner an answer sounds, the more likely it is that someone smoothed off all the interesting edges to make it fit through the door of public understanding. And physics, real physics, the kind that happens in papers and arguments and late nights at blackboards, real physics is almost never clean. It is almost always stranger, messier, more uncertain and more breathtaking than whatever version got summarized for the textbook. So here is what I want to give you today. Not a debunking, not a conspiracy theory about scientists hiding the truth. What I want to give you is something much more valuable than a new answer. I want to give you a better relationship with the question itself. I want to show you the exact place, the precise intellectual moment where even brilliant people sometimes stop asking. And I want to show you why you should keep going, why the question, what came before the Big Bang, is not a malformed question. Why it is, in fact, one of the most alive, most generative, most important questions that physics is actively wrestling with right now. Not in the fringe, not in the pseudoscience newsletters, in the journals, at the conferences, in the work of some of the most serious minds that have ever pointed themselves at the sky. But here is the other thing I want to give you, and this is the part that might surprise you. Because this video is, on its surface, about cosmology. It's about the origin of the universe, about time, about what the mathematics of reality actually says when you read it carefully, rather than just summarizing it for a test. But underneath all of that, underneath the physics, this is a video about what happens to a person when they stop needing a clean beginning, when they realize that the most important things in their life, the things that shaped them, the things that broke them, the things they've been carrying, don't actually require a fixed, definitive point of origin story. And that realizing this isn't loss, it's the beginning of something much more interesting than certainty. So let's start where every good question starts, not with an answer. With a picture, I want you to imagine a river, but not from the bank. Don't stand on the shore and watch it go by. I want you to imagine that you are inside the river. You are the water. You have no memory of the mountain spring that fed you. That was a long time ago, and water doesn't keep diaries. You have no sense of the ocean somewhere ahead of you, though something in the way you move suggests a direction. All you know in any immediate and real sense is this: the current, the cold, the particular pressure of being surrounded by more of yourself,
The way the rocks on the riverbed break the flow into tiny temporary whirlpools that disappear almost as soon as they form. Now, someone standing on the bank, a very smart someone, a well-meaning someone with good instruments and genuine curiosity. That person points upstream. They've been watching the river for a long time. They've traced it back as far as their legs could carry them. And they point at a waterfall, maybe a mile upstream, a dramatic and thunderous place where the river drops off a shelf of granite and crashes into the pool below. And they say, "That's where the river began." And here's the thing, they're not wrong exactly. The waterfall is the most visible dramatic event in the river's history. Everything downstream from the waterfall has the character it has partly because of what happened there. The water picked up minerals from that particular rock. The velocity of the fall shapes the current for miles. The waterfall is real and it matters, and the person on the bank who found it has done something genuinely impressive. But you, inside the water, you know something. The water that went over that waterfall, it was already the river before it fell. It had a history before the dramatic moment. It came from somewhere. It was shaped by 1,000 subtle things: snowmelt, underground springs, the particular tilt of the land, before it ever reached that shelf of granite and made that spectacular noise. The waterfall is not the beginning of the river. The waterfall is the beginning of the river that the person on the bank can trace. These are two completely different things, and confusing them, quietly, naturally, without even noticing the confusion, is one of the deepest and most human of intellectual habits. The Big Bang is our waterfall. I need to say that again because it deserves to sit with you for a moment. The Big Bang is our waterfall. It is magnificent. It is real. It is one of the most well-supported events in the history of scientific discovery. The evidence for it is extraordinary. The cosmic microwave background radiation, the distribution of hydrogen and helium in the universe, the fact that everywhere we look, galaxies are moving away from each other, which means if you run the movie backwards, everything was once much closer together, much hotter, much denser. All of that is real. All of that is as solid as science gets. But, and here is the draft through the door, the Big Bang being a real and important event in the universe's history is not the same thing as the Big Bang being the beginning of time itself. One of those is a cosmological observation. The other is a philosophical claim dressed in scientific clothing. And for decades, those two things have been standing very close together, wearing the same outfit. And most people, including honestly a lot of science communicators who should know better, have been treating them as if they're the same person. They are not. Now here's where I need to tell you something about the physics, something specific, something that the textbooks almost never say clearly, even though every working physicist knows it, and most of them find it either fascinating or quietly embarrassing depending on the day. There is a moment in the very early history of the universe, the earliest moment that our current physics can describe, called the Planck epoch. It refers to the first 10 to the power of -43 seconds after the bang, which is a number so small, it genuinely has no meaning in everyday life. It's not like a millisecond, which you can at least sort of feel. It's a duration so brief that even the word brief is almost offensively inadequate. But here's the thing about the Planck epoch. At that scale, at that density, that temperature, that compactness, the two great theories of modern physics, general relativity and quantum mechanics, stop working. They produce nonsense. They give you infinities where there shouldn't be infinities. They contradict each other. They break. And this breakdown is not a minor technical inconvenience that physicists are getting around to fixing when they have time. This breakdown is the most important open problem in all of fundamental physics. We do not have a theory of quantum gravity, a framework that successfully unifies general relativity and quantum mechanics at the scales relevant to the very early universe. We are working on it. String theory is an attempt. Loop quantum gravity is an attempt. There are others, but none of them have been confirmed. None of them are settled. At the Planck scale, our map literally runs out, not because we haven't looked hard enough, because the instruments we currently have, the mathematical instruments, I mean the equations, They were not built for that terrain. Now, here is the point I need you to really feel. The singularity, the beginning of the Big Bang, the t=0 moment, sits inside the Planck epoch. It sits in the exact region where our physics stops working. Which means that when physicists say time began at the Big Bang, what they are technically saying, what the mathematics is actually saying, if you read it honestly, is our current description of reality breaks down at this point, and therefore we cannot say anything about what was happening before this point using our current tools. That is not the same as nothing was happening before this point. That is not the same as there was no before. That is the map running out. That is the road ending at a cliff. The land continues. We just haven't built the bridge yet. And the moment you understand the difference between our description breaks down here and reality itself breaks down here, something opens up. Something in the question that was sealed shut gets pried open just a little bit. And through that crack you can see something remarkable. You can see that some of the most serious physicists in the world have been building different bridges. And while those bridges look quite different from each other, they all lead somewhere. They all suggest that the universe, in some form or another, did not begin when the story we can currently tell begins. Let me show you 3 of those bridges, and I want you to treat them not as competing answers to memorize, but as 3 different ways of standing at the edge of the unknown and choosing to lean forward rather than back. That, leaning forward, is, in my opinion, the most important thing a curious mind can do. The first bridge belongs to Stephen Hawking, working with James Hartle. It's called the no-boundary proposal. And to understand it, I want you to think about something beautifully simple. Think about the South Pole. Not the cold, not the penguins, just the geometry of it. The South Pole is the southernmost point on Earth, and here's a question: what is south of the South Pole? Take a moment with that. Most people, when they really sit with it, start to feel the question become strange in their mouth. It's not that the answer is nothing. It's that the question itself starts to dissolve. The South Pole is the point where south as a direction simply ceases to apply. You can't go further south than the southernmost point. It's not that there's a wall there. There's no wall. There's no beyond that is being blocked. The concept of further south just stops being a concept that works. Hawking and Hartle proposed that something structurally similar might be true of time near the Big Bang. They suggested that under extreme conditions, the kind of conditions that existed in the very early universe, time itself might have behaved more like a spatial dimension. It might have become rounded, the way the surface of the Earth rounds at the poles, and if that's true, then asking what was before the Big Bang isn't a question that's being blocked by a wall. It's a question whose terms, before, after, beginning, simply stop meaning what they usually mean. The concept dissolves, not because someone decided to forbid the question, because the geometry of reality in that regime doesn't have a place for before to live. Now, I want to be careful here because this is subtle. This is not the same as saying nothing happened before the Big Bang. It's saying that the category of before may not be the right tool for that job. It's saying that our temporal language, which works beautifully for everything from planning lunch to describing the history of civilizations, runs into its own kind of grammatical breakdown when applied to the deep architecture of space-time at extreme energies. And if that sounds strange and uncomfortable, good. That's what accurate thinking about the edge of knowledge feels like. If it felt comfortable, you'd know you hadn't really gone there yet. The second bridge was built by Roger Penrose. And I find this one genuinely beautiful, in a way that makes me feel something I can only call gratitude to be alive in a time when humans think thoughts like this. Penrose proposed what he calls conformal cyclic cosmology. And here's the core of it. Imagine the very far future of our universe. Not the next billion years, much further. The universe continues to expand. Stars burn out. Black holes eventually evaporate through a process called Hawking radiation. The universe becomes increasingly cold, increasingly thin, increasingly empty. Matter as we know it eventually decays. What you're left with, at the absolute end of this cosmic story, is a universe populated essentially only by photons. Light, moving through an increasingly vast, cold, empty space. Now here's the mathematical magic that Penrose noticed. In a universe containing only massless particles, particles moving at the speed of light, like photons, something peculiar happens to time. Massless particles don't experience time the way massive objects do. For a photon, the journey from here to the edge of the observable universe is, in a certain mathematical sense, instantaneous. A universe of pure light is a universe in which the conventional measurement of scale, of distance and duration, becomes meaningless. And Penrose recognized that a universe in this state is, in a deep mathematical sense, geometrically identical to a universe in an extremely hot, extremely dense, extremely compact early state. The cold, empty end of one cosmic cycle and the hot, dense beginning of the next are, under this framework, the same geometric object looked at from different directions. The end is the beginning, not metaphorically. Mathematically, the universe doesn't die and give birth to a new universe. It transforms smoothly and continuously from what looks like an ending into what looks like a beginning, with no break in between, no creation event, no moment of nothing. Time doesn't begin. Time loops, or more precisely, time transforms in a way that makes loop the closest word we have, though even that isn't quite right. There's a picture I carry with me when I think about this. A phoenix, but not the mythological kind made of fire and drama. A phoenix made of mathematics. A universe that transforms its ending into a beginning not through magic, but through the elegant and remorseless logic of geometry. I find that image more astonishing than any myth. The third bridge comes from a field called loop quantum cosmology, and this one is perhaps the most viscerally imaginable of the three, because it gives us something we can feel in our bodies if we try. You have, at some point in your life, compressed something. Squeezed a ball in your hand, pushed the air out of your lungs. You know that there is a resistance that builds as something gets compressed, a pushback, a pressure that grows as the thing gets smaller and denser. Now imagine compressing the entire universe. In the standard Big Bang model, this compression just keeps going, smaller and smaller and hotter, until you hit a singularity, a mathematical point of infinite density, and the equations break. But in loop quantum cosmology, there is a fundamental quantum of geometry, a smallest possible size. Space itself, at the Planck scale, is not infinitely divisible. It has a kind of granularity, the way a photograph has pixels. And when the universe compresses all the way down to that scale, the quantum geometry creates a repulsive force, a pressure that pushes back against infinite compression. The universe hits its smallest possible state, not a singularity, not infinite density, but a maximum density that the quantum geometry can support, and then it bounces. It bounces outward. The contraction becomes an expansion. What we call the Big Bang is, in this picture, the moment of maximum compression in a previous cosmic cycle, the moment the universe stopped collapsing and began to expand again. Our universe is on the other side of a cosmic breath held to its absolute limit and then released into everything we know. Think about that image, a breath held until it can be held no longer, and then released. Time doesn't begin at the Big Bang in this picture. Time passes straight through it, the way a river passes through a waterfall. The waterfall is real. The waterfall is dramatic. But the river was already the river before it fell. Now, you might be sitting there thinking, okay, but which one is right? Hawking and Hartle? Penrose? Loop quantum cosmology? And I want to answer that question with something that, the first time someone said it to me, I found almost offensive. And then, eventually, I found it to be one of the most liberating ideas I'd ever encountered. We don't know. Not we're close to knowing, not scientists are pretty sure it's one of these. We genuinely, honestly, carefully don't know. All three of these frameworks are internally consistent. All three are taken seriously by serious physicists. None of them has been confirmed by experiment. The domain in question, the Planck epoch, the first moments of the universe, is so extreme, so far outside anything we can recreate in a laboratory, that direct experimental confirmation may not be possible for a very long time, maybe ever. We are reasoning about it with mathematics and logic and theoretical consistency, the way you might reason about a crime scene from the physical evidence left behind long after the fact. And here's what I want you to understand about that. The fact that we don't know is not a failure. It is not an embarrassment, it is not a reason for cynicism or despair about the reliability of science. It is science working exactly as it is supposed to work, reaching its current frontier, marking that frontier honestly, and standing at the edge with openness instead of premature closure. The failure, if I want to use that word, is not in the physics. The failure is in how we talk about the physics. It is in the documentary narrator who says, "The universe began 13.8 billion years ago," without the asterisk that says, "at least as far as our current description can take us." It is. In the textbook that draws a timeline beginning at the Big Bang without acknowledging that the question of what sits before that point is actively open. It is in the teacher who silences the student who asks, "But what was before that?" with the South Pole analogy, which is, I want to be very clear, one possible and genuinely interesting answer, but not the only possible answer, and not a settled fact. The question is open. It is gloriously, productively, thrillingly open. And you are right to feel the draft through the door. There is something else I want to tell you. Something that is, in my experience, the most important thing you can take away from any serious engagement with the frontier of physics. It has to do with the psychology of certainty and why certainty, particularly about origins, is so seductive that it can become a trap even for very smart people. Here is a pattern I have noticed. When a scientist reaches a beautiful conclusion, a clean, elegant, final-seeming answer to a hard question, there is a very specific danger. The danger is not that they will get it wrong. Everyone gets things wrong sometimes. That's built into the process, and it's fine. The danger is that they will fall in love with the elegance of their answer and stop noticing the questions that the answer itself generates. The solution becomes a new lens, and the new lens becomes a new limitation. You start seeing everything in terms of the beautiful thing you found, and you stop noticing the shapes that don't fit. The Big Bang is, in a way, a victim of its own elegance. It is such a successful and genuinely astonishing framework for describing the early universe that it began to function in the public imagination as an origin story. And origin stories have a very specific gravitational pull on the human mind. We need them. We build our sense of identity, our sense of meaning, our sense of continuity around them. The universe had a beginning. Our nation had a beginning. I had a beginning, a birth date, a particular set of circumstances, an origin that explains what I became. And there is real value in those stories. I am not here to take them away. A person who has no story of where they came from is often a person who is lost. Origins matter. They provide context, they provide meaning, they anchor us in something larger than the present moment. But, and here is the thing that I want to sit with you in for a moment, because this is where the physics and the personal become the same conversation. The stories we tell about our origins are always simplifications. They are always partial. They are always, in a deep sense, the candle in the fog rather than the full illuminated room. Every person I have ever known, and I mean every single one, carries at least one story about when they became what they are, when they became afraid, when they became small, when they became the kind of person who doesn't get certain things, or doesn't deserve certain things, or is fundamentally different from the people who seem to move through the world with ease. There is a moment they point to, a waterfall, a beginning. Ever since this happened, I have been this way. And I want to ask you, gently and seriously, the same question that loop quantum cosmology asks about the universe. What if that moment, As real and as significant as it was, what if it was a bounce? Not a beginning, a bounce. What if the thing that felt like a creation event, like the moment you were made into whatever you're afraid of being, was actually a moment of maximum compression in a process that had been going on much longer? What if the river was already the river before it hit that waterfall? I am not asking you to minimize what happened to you. I am not asking you to pretend that the waterfall wasn't loud and cold and frightening. It was. Real waterfalls are. But the river exists before the waterfall. The river continues after the waterfall. The waterfall is not the definition of the river. And here is the neuroscience underneath the metaphor, in case you want something more grounded than poetry. The stories we tell about our origins, the narratives that begin with "ever since X I have been Y," those narratives are not passive records, they are active processes. Every time you recall and retell an origin story, you are literally reshaping the neural pathways that store it. Memory is not a photograph. Memory is a reconstruction, and it is a reconstruction that is influenced every single time by who you are at the moment of remembering, which means that the story of your beginning is always being written in the present tense, even when it feels like it's describing the past. Which means that the question, is this origin story the whole truth, or is it the candle in the fog, is not a question about the past. It is a question you are answering right now in the act of remembering. It is a present tense question with a present tense answer. And you have more choice in that answer than you might think. This is not a self-help platitude. This is physics applied to selfhood. The map is not the territory. The story is not the life. And the moment you understand that even the universe's beginning might be a story we're telling about a map that runs out, rather than a fact about where reality starts, well, something in the chest loosens. The question of where you began loosens with it. So let me give you something practical. 3 things you can actually do, starting today, with what we've been talking about. Not because I want to turn a physics lecture into a self-improvement seminar, but because I genuinely believe that ideas that don't change how you stand in your day are just entertainment. And I like entertainment, but I like it better when it also changes something. The first thing is what I call the origin story audit. And it's very simple, which means if you actually do it, it will probably be more powerful than it sounds. Take one story you tell about yourself that contains the phrase, or the feeling of the phrase, "Ever since this happened, I have been this way." Just one. Write it down as a single sentence if you can. Try to be specific, not "ever since I had a hard childhood." That's too large to work with. Something smaller and more precise. "Ever since I failed that test in front of the whole class, I've believed I'm not smart." Or, "Ever since that relationship ended the way it did, I've believed I'm too much for people to handle." Write that sentence, hold it, and then ask the physicist's question, is this moment actually the beginning? Or is it the first thing you could clearly see from where you were standing? Is it the waterfall, dramatic, visible, formative? Or is it actually the beginning of the river? What was already in you before that moment that made the moment land the way it did? What had been building? What existed in the fog before the candle? You don't need to answer that today. You don't need to rewrite the story. The act of asking is enough, because the act of asking is how you distinguish between the map and the territory. And the moment you notice that your origin story might be a map, you have already expanded the territory slightly. The room gets bigger just from the question. The second thing I want to give you is what I call sitting at the plank wall. This is a brief daily practice, and when I say brief, I mean it takes about 1 minute, maybe less. Once a day, morning coffee, evening walk, a moment in your car before you go inside. Ask yourself this: what is the question I have been refusing to ask because it seems like it doesn't make sense? What is the thing I keep almost thinking about and then steering away from? What is the door that has a draft coming through it that I keep not walking through? Write it down or just hold it. Don't demand an answer from yourself. The question is the practice, the Planck wall in your own life, the place where your internal equations produce nonsense, where you run into infinite confusion or infinite resistance. That wall is not a sign that you've hit a dead end. It's a sign that you are standing at your own frontier. That's the place where the most interesting thing that could happen to you is waiting. And learning to stand at that wall without panicking, with curiosity instead of dread, is one of the most important skills a person can develop. It is exactly what distinguishes the physicist who goes beyond the known from the one who stops at the edge of the map. Comfort yourself with this. The universe has a Planck wall. Reality itself hits a place where its description breaks down and the equations produce garbage. And the universe is doing fine. It didn't freeze at that edge. It is, apparently, still going. So are you. The third practice is borrowed from the bounce cosmology, and I want you to use it specifically for the moments that feel most like endings. Relationship endings. Identity endings, the times when whatever you thought you were no longer seems to fit and you don't yet know what you're becoming instead. The times of maximum compression. In those moments, not in spite of the pain, but right in the middle of it, try holding the following question. Not as denial, not as forced optimism, as a genuine structural inquiry. Try asking, what if this is the compression before the expansion? What if this is not the end of the story, but the part of the story where everything gets pressed so tightly together that the only possible next thing is an outward movement? What if I am, right now, at the point of maximum density, and the bounce is already built into the physics of this moment? I am not asking you to feel good about something that hurts. I am asking you to hold it differently. The universe's bounce was not comfortable. Maximum compression is, by definition, the place where everything is at its most intense. But the direction changed. The direction changed because the physics demanded it. And sometimes, more often than you might expect, that is also true of us. You don't owe your difficult moments an identity. You don't have to become what the hardest thing that happened to you would have made you. The bounce is real. The expansion is real. And it doesn't require you to pretend the compression wasn't what it was. Now, I want to come back to the physics one more time before we end, because I want to make sure I've given you the full picture honestly. There are people who will tell you that the questions I've been raising, the no-boundary proposal, conformal cyclic cosmology, loop quantum cosmology, all of it are speculative. And they're not wrong. All of these are speculative. They are well-reasoned, mathematically sophisticated, taken seriously by serious people, but not confirmed. We don't have the experimental data to choose between them, and we may not for a very long time. And I want to say clearly, that's okay. That is not a problem that needs fixing. That is the honest state of affairs at the frontier of knowledge, and honesty about the frontier is one of the things I value most in science and in life. What I want you to reject is the false certainty that runs in the other direction. The confident assertion that time began at the Big Bang is also speculative in the relevant sense. It is a claim about what was happening before our current physics can describe, which is a claim that our current physics, by its own admission, is not equipped to make. The silence of our equations at the Planck scale is not evidence that nothing was there. It is evidence that we don't yet have the right equations for that regime. And there is a profound difference between our tools don't reach there and nothing is there. We live in a time when uncertainty has gotten a bad reputation, when not knowing is treated as weakness or as a failure of intelligence or as an invitation for others to fill the vacuum with whatever they're selling. I understand why people react that way. Uncertainty is uncomfortable. The unknown is where fear lives. A clean answer, even a wrong clean answer, feels better than an honest, open question. But I have spent my whole life at the edge of what is known, and I want to tell you something about that place. It is not cold there. It is not empty. It is, in fact, the most alive place I have ever been, standing at the boundary of what can currently be described, with the full acknowledgement that something is there beyond the boundary. and that I don't yet know what it is. That feeling is not anxiety. When you get used to it, when you stop fighting it and start welcoming it, it feels like standing at a door that is about to open. It feels like the moment just before a really good question gets asked. And you know what that feeling is in the body? It is curiosity. Pure, uncontaminated, pre-answer curiosity. The feeling a child has before they've learned which questions are allowed and which ones make the grown-ups give that patient smile. I have been trying to get back to that feeling my whole life. I have found it most reliably at the exact places where the map runs out. You had that feeling too. That's why you're here. You felt the draft. So let me leave you with this. The universe, as far as our best and most honest physics can currently tell us, does not require a beginning. It does not need a t=0 to function, to exist, to be what it is. The appearance of a beginning may be a feature of our description rather than a feature of reality. The map has an edge. The territory, as far as we can tell, may not. What an extraordinary thing to sit with. What a gift that is, actually, if you let it be. Because if the universe can exist without a clear, definitive, universally agreed-upon starting point, if the cosmos itself is comfortable in the territory beyond the edge of the map, then maybe you don't need one either. Maybe the story of when you became what you are, when you were first broken or first limited or first made afraid, maybe that story has the same relationship to your actual self that the Big Bang has to the actual universe. Real, important, formative, but not the whole picture, not the beginning of the beginning, not the final word on what you are or what you are capable of becoming. You are not your origin story. You are the river, not just the waterfall. You were not created at the moment of your greatest compression. You were already moving before that. You will be moving after it. The bounce is built into the physics. And the questions you've been afraid to ask, the ones that seem malformed, the ones that get the patient smile, those are the most important ones you have. Those are the doors with drafts coming through them. Those are the places where your map runs out and the territory gets interesting. Don't stop at the wall. The wall is not the edge of what's real. The wall is the edge of what your current tools can describe, and new tools are built by the people who stood at the wall long enough to fall in love with what might be on the other side. The universe doesn't know exactly where it started. It's doing just fine. You don't need to know exactly where you started either. What you need to do is stay curious. Stay honest about what you don't know. Keep asking the questions that feel malformed. And trust the current you're already in, because the river was always moving, long before the waterfall, and it will keep moving long after. That's physics. That's also, I think, how to be alive. If something in this conversation gave you something real, if you felt, even for a moment, that the room got bigger, that the question you'd been told not to ask was actually a very good question, then we've been thinking in the same direction today, you and I. And I'm glad you're here. Hit like if this gave you something worth sitting with. Drop a comment with the question you've been afraid to ask. I mean that seriously. I love those questions more than almost anything. And subscribe if you want more conversations that start where the map runs out. That's where I'll always be, at the edge, leaning forward, listening to the draft. See you there.